Okay, good morning. I see Anderson on. I think that's the only person that's on. Okay, so I'm going to continue on with vectors. We're going to look at addition of vectors today. So when we add vectors, we have to make sure that we're placing them tip to tail. So if I were adding vector u plus vector v, I would place u and then v, the tip of u and the tail of v go together. So it's tip to tail. So the tip of the first one and the tail of the second one go end to end, and then the resultant vector is from start to finish. Okay? So it's kind of like going around a field or diagonally across a field. I'm just going to fix this smart board a little bit. It's a little bit off. And sometimes you'll see it, they call it the parallelogram addition. So if I have u plus v, you'll see it like this. So we're adding these two together. They would move the v over to the tip of u, and that creates a parallelogram. Right, so then the resultant is from the corner, the diagonal to the diagonal. So this would be u plus v. So it creates a parallelogram. So sometimes you'll see it like that. Okay. So if we have this object here and we're expressing the following as a single vector, so these should have lines on them. So if we are adding vector AB plus vector BF, if we look on the model here, A to B, so remember that order matters, so you're starting at A and ending at B, and then we're adding B to F, so we'll go tip to tail, and so the resultant vector would be A to F. Where I started and where I ended is the resultant vector. So A to B and B to F, oops, would be vector A to F. So starting at A, ending at F is where I ended up. And you'll notice that the middle, the last number in AB is the same as the first letter in BF, right? They have to be the same. That ensures that it's tip to tail, right? The tail of AB is the same value or variable as the tip of B to F. Okay, here we have to add, let's erase this. So here we have to add AE plus E to F. So A to E is this vector, and then we'll put the tip of that to the tail of E to F, which is that vector, and we end up with vector, again, A to F. We just went in the other direction. So A to E plus E to F equals vector A to F. That is the resultant. And again, you'll notice that the A to E ends in E, which is the tip of A to E, and it matches up with the tail of E to F. Okay, let's erase this. Now we have A to E. So we could add 3 vectors, right? It doesn't have to be just 2. We could add 3 and look at the resultant. So here we're adding A to E, and then the tip of that goes to the tail of E to H, and then the tip of that goes to the tail of H to G. And so the resultant is the starting point and the ending point. Right, so that's where we started at A and we ended at G. And then we did tip to tail all the way through. And so our resultant is A to G. Okay, so that's fairly straightforward. I could add those without the diagram because I can see that the tip of A to E matches with the tail of E to H. So that vector would be A to H. And then again, I could add A to H plus H to G because the tip of that matches the tail of that. So that would give me A to G. So it's nice to have the diagram, but you can also add them if you didn't have the diagram. You could just make sure that the tip of the first one matches the tail of the second one. Okay, so here we have to express each sum as a single vector. So a to b plus b to c. I could look at the diagram, or I could just add it as it is. I can see that the tip of a to b is b, matches with the tail of b to c. So starting at A, I would end at C, and on my diagram, A to B is here, B to C is here, and so the addition is from A to C. Okay. B is A to C plus C to D. So just making sure that the tip A to C matches with the tail of C to D, so that would be A to D. Let's do one more. I'll just skip over to E. So E has three vectors, CA plus AD plus DB. So maybe I'll do this in two steps. So C to A plus A to D. The tip of C to A matches the tail of A to D, so that would be C to D. And then C to D plus DB would be CB. Okay, so the diagram is handy, and sometimes you might just get the diagram. Sometimes you'll get it written out in vector form. Either way, it's easy to add. Okay, now I want to look at subtraction of vectors. Just give me 1 second. Okay, so here we have subtraction of vectors. Get my screen up here. Okay, so remember that subtraction is the inverse operation of addition. So when we subtract vectors, we're really just adding the opposite. So if I want to subtract A minus B, I'm really adding A to the opposite of B. So A plus negative B is the same thing as subtraction. So for example, and remember we have to have tip to tail be the same. So if I were subtracting AB minus FB, well, first of all, the tip of AB is not the same as the tail of FB. But I could, if I want to add the opposite, right? If I took the opposite of FB, it would be BF. Right? So think about this. If we have F to B, the opposite is B to F. So subtracting F to B is like adding the opposite of F to B, which is B to F. And now the tip and the tail match up, and that would give me A to F. Okay, so if we look on a diagram, it might make more sense on a diagram. So I want to subtract A to B minus H to D. So I have A to B, and I want to subtract H to D. So H to D is this one. Okay, so first of all, they're not matched up tip to tail. So I'm going to look at H to D, and I'm going to add the opposite. So the opposite would be D to H. But that still doesn't match up with tip to tail with A to B. But I know that all these vectors are equal, right? Any vector that goes from, so D to H is equal to C to G, is equal to A to E, is equal to B to F, because they are parallel and they have the same magnitude. So I could say that A to B plus D to H is the same as adding B to F, because D to H is equal to B to F. So I'm going to do tip to tail there, and so that now I can add those together, and I would get a resultant vector of A to F. So not only do we have to turn D to H around, so we wanted to add the opposite, but we also had to use an equal vector so that we could put our vectors tip to tail. Okay, so let's look at the next one. Okay, so we have H to E minus B to A plus G to C. So H to E, let's look on the diagram. So HE is this one. And we want to subtract B to A, which is this one. Okay? Well, B to A is equal to F to E, first of all. Right? These are two equal vectors. So I want a vector where I can place it tip to tail, but F to E, right? So I'll just do it this way. So H to E minus, and then instead of B to A, I'm going to put F to E because they are equal. And then I want to add the opposite. So instead of subtracting F to E, I'm going to add E to F, right? So subtraction is the same as adding the opposite. So I'm turning this one around, right? So instead of subtracting E to F, I'm adding F to, instead of subtracting F to E, I'm adding E to F. So now we're going from here to here. So that ensures that it's tip to tail. Kind of like a little puzzle. So now I can add H to E plus E to F. That gives me H to F. So now I want to add H to F plus G to C. So G to C is this one. Well, that does not land tip to tail, but it is equal. An equal vector would be F to B, and that would be tip to tail with E to F. So instead of adding G to C, we're going to add F to B. And so now we can add these together because the tip of HF matches the tail of F to B. So my final result is H to B. Okay? So we had to turn around F to E. Well, actually, we had to replace AB with an equal vector, EF, and turn it around, so add the opposite. And then we had to replace G to C with an equal vector, which was F to B, and then we get our final result of H to B. Okay, so that's all we're going to look at right now for vectors before we get into our addition of vectors as applications. Subtracting